Question 1b. A long glass rod has a concave end having a radius of curvature 20 cm and a refractive index of 1.5. An object O is placed at a distance of 30 cm from the spherical surface. Find the location and the nature of the image formed by the refraction at the spherical surface. So a different question from the previous one, where this is a refraction at the spherical surface. So this is the spherical surface we have. So the previous question we have answered is a reflection on the spherical surface, where this is the refraction. So usually refraction happens between two medium. So the medium that we have here is the glass, which is with a refractive index n equals to 1.5, and air with a refractive index of 1.0. And refractive index for glass and air is a constant, of course. Now let's list down the information we have, which is again refractive index of glass 1.5, refractive index of air 1.0. We are given the radius of curvature 20 cm and the object distance 30 cm. So the front of the spherical surface over here is on the left side, while at the back is at the right side. So as you can see, the object is placed in front of the spherical surface. And the spherical surface we have here is a concave end. And as you can see here, for a concave end, it is curved inward. So again, let's find out where the radius of curvature will be. So previously I've said about the center of curvature. The center of the curvature is basically the center of the spherical surface. So for this one, if we imagine that we draw a circle over here. So the center of curvature is somewhere over here. And the point where the circle, from the circle to the center of curvature is the radius. So our radius will be over there. And let me erase that one. So now let's determine our answer. So we need to find the location of the image form. Basically, we need to find the V. In order to find the V here, we're going to use the equation of refraction at the spherical surface. The equation is, as I've wrote down here, which is n over u plus n1 over u plus n2 over v equals to n2 minus n1 over r. So n1 is the refractive index of the incident ray. I will tell you what it means in a minute. Refractive index of the incident ray. So the refractive index for the incident ray in this case is the air, because the incident ray will be coming from the object, I ray over here. That is for N1. For N2 is the refractive index of the refracted ray. So the refracted ray over here will go through the glass. So now, before we answer the question on finding V, let's determine our sign convention for R and U. So again, we're going to use this table over here. So let's determine for U first. Is U in the same side as the incident ray? So the U is over here, which is the object distance. So as you can see, the U is in front of the spherical surface and it is in the same side as the incident ray, so our value for the sign convention for U is going to be positive. Now let's look at for R. So now for R must be in the same side as the refracted ray for it to be a positive value. And as you can see here, the refracted ray is through the glass from the incident ray here and then refracted through the glass. And we can see that R, the radius of curvature, is on the opposite side from the refracted ray. So our R will be a negative value. So now since we have determined the sign convention for U and R, we can plug in our numbers to get the answer. So N1 refractive index for air is equal to 1.0 over U object distance 30 centimeter. So refractive index for glass 1.5 over V, what we are going to find. Again, refractive index of glass 1.5 minus 1.0 over negative 20 centimeter, which is the radius of curvature. Rearrange to get V, you will get negative 25.7 centimeter. Right, now that we have our value for V, which is a negative value, we can answer the next question, which is the nature of the image form, which is the characteristic of the image. So since the V is a negative value, we know that the image form is going to be virtual, and any image form that is virtual, it's going to be upright. So we can note that down over here. So the image form, if we draw it on our diagram over here, it will be somewhere on the same side as the object. Instead of at the back or forming on the glass, it will form at the same side as the object, not the opposite, because this is a virtual image. So if it forms opposite side as the object, let's say somewhere over here, it would be a real image, real and inverted image. But in this case, it is a virtual and upright. So it should form at the concave end, in front of the concave end, on the left side, which is on the same side as the object. Now let's go through the next question.